Hello children, welcome to 8th chemistry online classes. Materials, metals and non-metals. So in this chapter, in the last class, we learned the physical properties of metals and non-metals. The physical properties of metals are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. The examples of metals are iron, copper, aluminium, calcium, magnesium, gold, silver, etc. And non-metals, they are generally soft or brittle. They are not lustrous, they are not malleable, they are not ductile, they are not sonorous, and they are poor conductors of heat and electricity. The examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc. And we studied that metals generally they are hard. But metals like sodium and potassium are soft and can be cut with a knife. Like a soap, we can cut with a knife when you are cutting a soap piece with a knife. Same like you can cut sodium or potassium metals. And another exception is generally all metals are solid in state. But mercury is the metal, and that is the only metal which is found in liquid state at room temperature. So note these exceptions. Okay children. Today we will learn the chemical properties of metals and non-metals. So first we see chemical properties of metals. First one, reaction of metals with oxygen. So very important children. So first reaction of metal is with oxygen. So first reaction you can see here, that is rusting of iron. This you learned in class 7, rusting of iron. So you can see here the picture also, rusting of iron. So how the rust formed? This iron react with oxygen from air and a water vapor in the air to form rust. And we studied in the last year how we can protect the iron from rust by painting or applying oil or something. We can protect iron. So the rust is formed by this reaction, iron plus oxygen from air plus water gives rust. So I'll give the chemical name also, iron. Iron we can represent by the letter Fe plus oxygen, O2, that is from air, O2 from air, and water, H2O, H and O capital letters, okay, H2O, to form rust. So chemically rust is iron oxide, Fe2O3. So this reaction you have to learn, okay, iron plus oxygen plus water to form rust, and chemical name of rust is iron oxide, that is Fe2O3. So here iron is the metal, and that metal react with oxygen to form oxide, iron oxide. And a second example is magnesium ribbon. I think this I showed last year. This magnesium ribbon burned. So burning, the oxygen gas helping for burning. So magnesium react with oxygen. Got it? So burning of magnesium means magnesium react with oxygen in the atmosphere. So magnesium plus oxygen gives magnesium oxide. Magnesium oxide. So magnesium Mg, we can that is represented as Mg, and you just see M is capital letter and G is small letter. Okay, magnesium Mg plus oxygen O2. Just see how to write this O2 gives the product. This is the product, magnesium oxide. Mg, that is magnesium, and oxide O, magnesium oxide. So in the first reaction here iron oxide, and the second reaction magnesium oxide. So in the both cases oxide. So in the picture you can see the magnesium burned in oxygen. And the third example is copper. Copper is also a metal, Copper is also a metal, and it is represented as Cu, capital C and small letter U, Cu. It reacts with oxygen, that is O2. Oxygen O2 gives copper oxide. Copper oxide, that is CuO. So that is a black color thing. Copper oxide is a black color. So that is also one example of reaction of metals with oxygen. And fourth example, aluminium plus oxygen gives aluminium oxide. That is Al. Aluminium represented as Al, O2, oxygen is O2, and aluminium oxide is Al2O3. So that is also oxide form. So reaction of metals with oxygen, generally we can tell like this. When metals react with oxygen, they form metal oxide. Okay, so this very, very important. Metals react with oxygen to form metal oxide. And in your textbook, page number 47, you can see in a box, a yellow box, it is given like that. When a copper vessel is exposed to moist air for long, it acquires a dull green coating. Copper vessel. Okay, copper is a metal, and copper having a brown color. So that copper exposed for a long time in the moist air. Is in the dry place, so nothing happened. But in the moist air, we keep for a long time, it will react with some other materials to form some green coating. The green material is a mixture of copper hydroxide and copper carbonate. So that green color means actually it is what? That is a mixture of copper hydroxide and copper carbonate. And the copper hydroxide chemically we can read like that, CuOH twice. CuOH twice. And copper carbonate is CuCO3. CuCO3, copper carbonate. The following is the reaction. Okay, and that so all of you open your textbook and just see the page number 47. So you can see that reaction. 2Cu plus H2O. H2O means water. Cu means copper. H2O plus CO2, that is carbon dioxide, plus oxygen gives copper hydroxide, that is CuOH twice, plus copper carbonate, that is CuCO3. Okay, so that in that box, just read in that in your textbook. Nature of metal oxide. Is it acidic or basic? So now we learned that generally a metal reacts with oxygen to form metal oxide. Clear, all of you? Metal react with oxygen to form metal oxide. Now we have to check that metal oxide is acidic or basic. So this also you studied in last year, class 7. Using litmus paper, we can check is the material or matter is acidic or basic using indicator. So litmus is an indicator. First you see here, two colors of litmus papers are available, red and blue. Okay, red litmus paper and blue litmus paper. And when we dip these litmus papers, red paper and blue paper, in a base, acid and base that you studied, example of base, some sodium hydroxide. Okay, some hydroxides are the examples of base. So you just see this is a base. So when we dip this red and blue papers inside, what will happen to the red paper? Red litmus paper changed to blue. Here you can see red litmus paper changed to blue. But this blue paper doesn't have any change. Okay, so keep that in your mind. The red litmus paper changed blue when we dipped in base. But blue litmus paper doesn't happen in base. And here next, the same thing we repeated in acid medium. So red litmus paper, blue litmus paper, and these two papers we dipped in acid, acetic acid or citric acid or any acid. In that time, this red litmus paper doesn't have any change, but this blue litmus paper changed to red color. Okay, and neutral. Neutral means example water, distilled water. Okay, not tap water. Tap water may contain some acidic substances. So distilled water, that is neutral. So when we put these two papers, this red paper and blue litmus paper into it, there is no color change because the medium is neutral. Got it, children? So in the acid medium, which paper having change? Blue paper. Blue litmus paper turned to red. And in the base medium, which having the change? Red paper. Red litmus paper having a change. It could change to, turns the color to blue. Okay, so first you keep these all things in your mind and come here. So here what we have to do, we got metal oxide. Metal plus oxygen gives metal oxide. Now we have to check that metal oxide is acidic or basic by this litmus paper. So we got example. We can take one example: magnesium burn in oxygen or magnesium burn. We get magnesium oxide, that is MgO. That is look like ash. Okay, white ash. And that magnesium oxide we dissolved in water. So we will get magnesium hydroxide. That also you learned in last class. Last class means in 7th standard. If you have any doubt, you can just take your 7th standard textbook and learn or read that part one more time. Okay. So dissolve the metal oxide in water and tested for its acidic or basic nature by litmus paper. You must have observed that the red litmus turns blue. Okay, red litmus. So here also you can see that red litmus turns blue. Red litmus turns blue means what? The metal oxide is basic in nature. Okay, so all metal oxides like magnesium oxide or copper oxide or aluminium oxide or rust, that is iron oxide, these all are basic in nature. And how you find it is basic in nature? By doing the test with litmus paper. So first what you do, metal oxide dissolve in water, and that solution you dipped with a red litmus paper. So red litmus paper turns blue. You can confirm that metal oxide is basic in nature. So here in general, metal oxides are basic in nature. metal oxides are basic in nature. So two important things you studied. First one, metal react with oxygen to form metal oxides, and metal oxides are basic in nature. Next is reaction of non-metals with oxygen. Non-metal like sulfur or carbon, okay, the phosphorus, these are the examples of non-metals. So first we learned metals with oxygen. Metals with oxygen, we get what? Metal oxide. Okay, don't forget, metal plus oxygen gives metal oxide. Now we are going to learn non-metals, how non-metals react with oxygen. See, here sulfur. Sulfur is a non-metal. S. It is represented as S, capital S, plus oxygen. Okay, oxygen. That means burning, burning of sulfur. That is happening here. Sulfur react with oxygen to form sulfur dioxide. That is sulfur dioxide. So that is also oxide. That is also in oxide form. Metal also react with oxygen to form metal oxide, and here it is sulfur dioxide. Okay, that is SO2. See, when sulfur dioxide is dissolved in water, just compare with that metal oxide dissolved in water. Here sulfur dioxide, that is non-metal oxide, is dissolved in water to form sulfurous acid. Not sulfuric acid, this is sulfurous acid. So see the chemical reaction. Sulfur dioxide, that is SO2, react with water, that is H2O, to form sulfurous acid, that is H2SO3. Sulfuric acid is H2SO4. So this is sulfurous acid, that is H2SO3. Okay children, so don't be confused. This reaction of metals and non-metals, metals or non-metals with oxygen. Okay, so this chemical reaction you have to study. How you will study? Write and study. Okay, by heart that chemical name and that chemical reaction. See, now we'll check the non-metallic oxide is acidic or basic. The sulfurous acid, here we got sulfurous acid. Sulfur dioxide react with water to form sulfurous acid. So that is an acid. So that turns blue litmus paper red. So here you can see blue litmus paper, and we dip this blue litmus paper in sulfurous acid. Its color change to red. And what will happen when the red litmus paper dipped in this sulfurous acid? Nothing will happen, no color change, because that is red paper. Red paper doesn't have any reaction with acid. So here by this experiment we know that what? The non-metallic oxide is acidic in nature. Okay, so now read. In general, non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. Okay children, so this is our topic today. See, here only 3 slides. I took only 3 slides, but these 3 slides are very very important, and it is little bit hard also. Okay, so read first. I'm suggesting that first you watch this video at least 3 times, at least 3 times, and try to make your own note while watching. When you are watching, that time take one paper and write the important keywords, okay, or important points in your notebook. After understanding the concept very well, then only you have to go to the textbook. Otherwise you are not getting any idea, because this is chemistry, little bit hard. Okay, so first see the video 3 times. Okay, that is must. You have to watch the video 3 times Then you have to make your own notes in any paper, not in your notebook, any paper. You can just make out the points, then read the textbook. Okay, then I'll give some questions also, so try to find the answer and write in your notebook, by heart that answer. Okay, but understand the concept and by heart. Okay, but that chemical reactions you have to by heart it. And then you have any more doubts, you can ask at any time. Okay, children, so thank you, all the best.